Alright, so let's look at 4 different titration curves. The first one we're going to look at is a weak base and flask with a strong acid. Here we start with a strong base. It goes into the buffer zone, which is a mixture of weak base and weak acid. It passes the pH of 7, and when it hits its equivalence point, when we're at a weak base in the flask to a strong acid, which is in the burette, we get a pH that's going to be less than 7, and then it goes down to the strong acid. Now let's take a look at a strong base with a strong acid. So when we're looking at the titration curve for a strong base in the flask with a strong acid, what we see is we go from a strong base to a pH of 7, which is our equivalence point, to the strong acid. Do not forget, at the pH equals 7, we were at neutral ions. Now looking at a weak acid in the flask with a strong base, we notice we have a strong base up here, so that's the very end. So we start with a weak acid, and then it goes to the buffer area, and then we get our equivalence point, which is a weak base, which has a pH greater than 7, and then again we get to our strong base. Now our final titration curve is a strong acid in the flask with a strong base. Again, we start with a strong acid. It goes to its equivalence point, which is pH equals 7, where we get neutral ions, and then it goes to its strong base. So one thing to keep in mind is changes in organic molecules are created and destroyed largely by acid-base reactions. So when we have our acid goes with water, we get our base plus our hydronium. Well, this will be a no charge, and this here will give us an anion. So here we don't see any charges, but here we do. We get this anion, and hydronium is what we get as a side product. Now when we do the base, we have our base plus water. We form a cation right here. So again, we have no charge, and then we form a cation. Now, why is this important? Charges are essential to biological structures. So for example, we have a micelle where it is hydrophobic. That means it doesn't like water. And right here, so right here to here is hydrophobic. Right here at the head is hydrophilic. It likes the water. So depending on if we put it in whatever solution, we can either get a micelle that looks like this, or we can get an inverted micelle, which looks like this, depending on what type of solution we put it in. So having charges is very important. Now, one thing I also want to discuss, polyprotic acids. They are all weak acids except for sulfuric acid, H2SO4. Remember, that is a strong acid. They will have several equivalence points, and the reason for that is because of the different Kas they have. So if we remember, when we were looking at phosphoric acid, it had 3 Kas. So that means it's going to have 3 equivalence points. So it's something to be mindful, and I do have a problem I'm going to have you work on to look at these. Alright, so your assignment, I want you to go over Chapter 19, Section 2. The problems I want you to do is 44, 54, 55, 56, 57, 58, and 60. There are detailed solutions for problems 54 through 57 on the Chem21 website that you can click on from your Blackboard page. I recommend strongly to do 54 through 57. It gives you great practice with a weak acid to strong base, strong acid to strong base, strong base to strong acid. and a weak base to a strong acid. So there are great problems for you to practice, and if you have any questions, please come seek help. So this is it for chapters 19.2.